So today, good morning students. Today we are going to discuss about the next part of our lasers, that is a component required to make a laser. What are the components required to make a laser? Just like we have discussed an example that to make a refill pen, we need a refill, an ink, and then the body of this part. So same is the case here. We know that laser is a process of light amplification by stimulated emission of radiation. To get the emission, there should be absorption should be there. So absorption cannot be takes place by itself. So the absorption is being done by providing the energy. So the energy has to be provided from the external source. So to provide the energy from the external source, the first component which is required is called as a pump. Pump is a pump is a instrument which provides the energy to the lasers. Any kind of lasers, we need a pump. Pump could be of any form. It could be optical pump, it could be electrical pump. So if it is an optical pump, so optical pump could be again of two type. One is by optical instruments, optical instrument. Another is by optical source. So optical source could be any light source which could be providing light energy. So it could be xenon flash tube or it could be argon arc lamp. So both of them can provide the light radiation. So these they are so energetic source that they provide very high amount of energy to the source. And why they are required? Because once the energy is being provided, the atoms absorb the atoms gain energy and goes to the excited state and then go to the metastable state, and then the process of stimulated emission takes place. So without stimulated emission, no laser action is going to take place, and without excitation, no laser action takes place. So without absorption, no laser will be there. So absorption is essentially required, and absorption will occur only when the source is being there. So pump, without pump, no laser action will be there. So pump is one of the essential component. So then xenon flash tube and argon arc lamp, they are the instrument which provide very high amount of energy, approximately 1000 joules of energy in a fraction of second. So but such some materials are very sensitive to heat, so such kind of pumps cannot be used. So for that we use an ordinary instrument where we can take the two mirrors which are being attached end to end, and then we keep the ordinary source at the one end and the material of the laser at the other end, and they are arranged in a such a way that maximum light should be get focused after reflection from the mirrors at the particular point. So we know that when the maximum light is being focused, they transfers maximum amount of energy and excitation of radiations takes place. So this is how the second part will be taken place, that is by using ordinary light source we can able to excite the pump, excite the source. So the absorption can be done by optical instrument or by using the xenon flash tube or argon arc lamp. But in some other cases, other kind of pumping is required, that is gas lasers like electrical pump, which consists of electrical supply or discharging of gas. Discharging of gas can be done by radio frequency source or any other source. Electrical supply can be done by using optical simple your say battery or cells are being required. You have seen when a small child take a battery laser, so he has some cells are being attached to it, so that cells is like an electrical pump which has been acting over there. So that electrical pump will cause absorption of the radiations to takes place. Now that was the first component which is being required for the laser action to takes place. Now what about the second? Now second component is the medium. So medium is again second medium which is being required for the laser action to takes place. Without medium, no laser will be there. So medium could be of any type. Everybody knows it could be solid, it could be liquid, it could be gas, it could be plasma. So since we have to discuss only different lasers of solids or gas lasers, so we need nothing to deal about the liquid and plasma laser. So among solids and gas lasers, we have different lasers which are in our course. So for Solid for about solid lasers, we have got ruby, semiconductor, and Nd:YAG laser. Ruby is a crystal, semiconductor is a material made up of semiconductors, Nd:YAG is again a alloy. So out of these, we have only these two are in our course. We need not have to discuss about this one. So then about the gas lasers, we have got helium neon and CO2 lasers, which are being there in our course. So all these are acting like a medium. So medium is just like a part which help in excitation of the atoms to takes place. Again, if there is no medium, no laser will be there. So that means without pump, without medium, no laser action will be takes place. Now the third essential component is called as resonator. Resonator. So resonator is an again essential component which is being required. Now what is being done? So we take a crystals material. I am just taking the example of a solid laser. We attach two mirrors at two ends of the crystal. So one end and the second end. So one end is being 100% reflecting, means fully polished. Fully polished or 100% reflecting mirror. So and in the other end it is 98% reflecting, and it is partially unpolished. Partially unpolished means 90% is polished, very few part is unpolished. So this function of the resonator is that to maintain the coherence in the laser beam. How? When the laser action takes place, as soon as the atoms get emitted during the spontaneous absorption or during the spontaneous emission, so they may cause stimulated emission to trigger out. For example, we have seen that one photon may cause one atom to come back, it emit two photons, and two photons may cause two atoms to come back, they may emit four photons. Now these four photons, they strike to the mirror. So as they strike the mirror, only fraction part of the energy will be released. That is 2% of the four photons will be released. Rest of them will be get reflected back. Now in the next diagram we will explain it out, and sorry, in the next part. So all the four photons, they will be emitted out, come out from this one, and they get reflected back from this end. Now what they four can do, they cause emission of the four another atoms to come back, and emission of 8 photons, and 8 will cause emission of 16 photons. Now 16 photons will strike over here. Once they strike over here, so there will be no emission of the radiation will be takes place. So these emissions atoms will be emitted out and causes further 16 to be emitted, and this process continues and till next laser will be emitted. So, and this process continues till all the atoms over here in the excited matter stable state get decayed. So that means if the number of atoms are less, so the process will vanish out soon. If the number of atoms are more, so the process will work out for a longer duration. So that means for to that we need additional things, that is called as we need a process in which more number of atoms should be there in the matter stable state. So the resonator helps in maintaining the beam to move in a one particular direction and helps in achieving the coherence of the beam. So that means these are the three components which are being very primarily required. Then there is a fourth component which is a secondary component which is not required in every lasers, that is called as coolant. Coolant. Coolant is a device which help in absorbing the heat emitted during the generation of the laser. So as we know that during the transition of heat radiations from one state to the another state, a lot of radiations are being emitted out. A lot of radiations are being emitted out. So these radiations will cause thus either by spontaneous absorption or by spontaneous emission or by stimulated emission, they may cause the laser action, the material to be get warm up. So if we do not absorb the heat, if we do not remove out the heat, what happens during a long number of transactions, the material gets heated up and it may cause damage to the material. So to maintain that, to maintain the coherence of the beam and to get the material should work safely, so the coolant is being required. So the coolant required is being provided by either by providing the water supply, Since we can do it by different method, either by using a cold water. Once we use a cold water uh, after every operation, so we have to replace it out, because after few operation the water may get heated up, it may cause damage to the tube or material also, because once it get heated up, instead of cooling, it will be providing the energy to the material. Next is by doing uh, flow of water. How we will do it? Now, we provide inlet and outlet to the material in such a way that the water should be come out and goes and circulated in such a way that the water should be um, this water should be continuously emitted out and coming out, so that the fresh water you can use it out, and heated water should be emitted out, and that will work for a longer duration. So that is another kind of coolant which is being required. So this coolant help us in maintaining the heat part of the lasers. In case of gas lasers, no such kind of coolants are required, because we already using quartz tube discharge, which is getting the material to be leaked. So this was all about the components of the lasers which are being required to generate the laser action. So in the next topic, we will discuss how the Einstein coefficients are related, 2 level, 3 level, 4 level lasers, and then different types of lasers, helium neon, semiconductor, ruby laser, and all these semiconductor one by one, and then how we can use them in different applications. Thank you.